So now for a rough as guts update on the evolution of this phased vertical array beam for 2 meters or any band. So like the previous videos, distance between here and here, here and here, here and here, and here and here is a half wave in free space. Element lengths are collectively 3/4 wave each, 4 of them. There are 3 parasitic reflectors, or just parasitic radiators. The center one is exactly a half wave in free space from this element and from this element. And there's also an additional parasitic reflector off to this side that is half a wave only from this one. And there's an additional one here that is a half wave from this one, to allow for tuning and to keep the system stable. Instead of like the original video having coax feeding to here, I have a parallel feed, so 2 parallel wires running at exactly a half wave in free space from the feed along the boom, and then at that point connecting to some coax and continuing along the boom. The coax feed is also measured out to be a half a wave, but with a 0.66 velocity factor. If you're using a different coax, that's fine. Make sure you measure it to be a half wave, factoring in its velocity factor. And then that's where we connect the, as the antenna feed point. So, and for tuning, the spacing between the parallel conductors will be a fine tune. It's basically a capacitive tune. So that's the fundamental principle. Same, everything else remains the same. So of course this side is one phase and this side is the other phase. Both of these, let's say, when current is being, let's say, driven on this side, it's being taken in on this side, and just like with a dipole, we would have coherence, currents running this way, then currents running this way, but because of the right angle, when currents are running this way, so being, let's say, positive on here and negative on here, we have downward on here and upward on here. And also, although these two are being fed exactly in phase, their spacing being a half a wavelength apart means that when this one has current running down, by the time the wave generated from that reaches here, although this had current running down at the same time, this now has current running out. So from here to here, we have a cancelling. And from here to here, we have a cancelling. And even so, at any given time, because these two are actually on the opposite phase, at any given time, we have up run here and down run there. And just like a balance line, cancelling. So double whammy cancelling, and the 3 different parasitic radiators cause a disruption and reflection, if you like to call it reflection. In other words, creates a higher impedance for the radiation in the back angle and the backside angles, which then forces what would have been a very strong bidirectional pattern to become a very strong, even more strong forward direction pattern. 7-3, and thanks for watching.